Hi everyone, this is Bincy Madhur, Maths teacher. Today I came with the first topic of Class 9, Chapter number 1, Number System. This is video number 1 of this series. In your previous class, you might have done the number represented on a number line. You have represented various numbers on a number line. The numbers which is 1, 2, 3, 4, 5. This type of number is natural number. If we include 0 in that, 0, 1, 2, 3, 4, 5 and so on is whole number denoted by W. The smallest whole number is 0, but the largest whole number cannot be determined because every number has its successor. Next type of number is integers. We need some negative numbers. Why we need the negative number is rupees 200 and rupees 200 does not make a sense. But if you write down gain and loss of rupees 200 simultaneously, when you show the opposite of two things simultaneously, then we need a sign positive and negative. These sign shows the directional numbers. Next, rational number. Any number. Can we get any number in between 1 and 2? Yes. There are infinitely many numbers between 1 and 2, 2 and 3. So the numbers like between 2 and 3, we can get 2.1, 2.4, 2.8, 2.9538 in this type of number where we will represent it. Obviously between 2 and 3. The numbers which is in the form of P by Q, where P and Q are integers and Q cannot be equals to 0. This type of number is known as rational numbers. And the numbers, we get many numbers which is not rational. We can represent any number on this number line which is not rational. That number comes under irrational number, which we cannot represent in P by Q form. You might be surprised, Pythagoras is not only famous for giving Pythagorean triplets or Pythagoras theorem, but also he has found the irrational numbers too. Now, let us see the decimal expansion of rational numbers. 10 by 3. When you find out its decimal expansion, divide it by 10 by 3, you will get 3.33 recurring number. While 7 by 8, the answer is 0.875. Here we find out the remainder is equals to 0. But for 1 by 7, we get 142857. Again after 7, it will repeat 142857 and so on. So by its decimal expansion, there is one more definition for rational and irrational is these all are rational numbers. Why? Because either it is terminating or it is non-terminating, but when it is non-terminating, the digits are repeating. In terms of decimal expansion, we can define the rational numbers are all terminating or recurring decimals are rationals. For example, it can be terminating 3.385, 1.7272, digits may be repeat, 1.572222 and continuously repeating. These are the examples of rational numbers. Irrational numbers all non-terminating and non-repeating decimals are irrational. The examples are all square root of non-perfect numbers like root 2, root 11, root 5, root 17, root 24. All these are irrational numbers. 1.01, 001, 0001. All these are irrational number. Now the question is 0 a rational number? Yes. 0 is a rational number because 0 can be what? Let us check its definition. Rational numbers are the numbers which we can express in p by q form. So 0 we can express in 0 by 1, where 0 is an integer and 1 is also integer and denominator is not 0. Yes, 0 is a rational number because it can be expressed as p by q form. Please take a note of this. Let us see some examples now. First question is, express the following decimal in p by q form. If the decimal is terminating, you have already did in your class 8, 3.142678. The method is 3142678. We multiply and divide by that many zeros. Means 1, 2, 3, 4, 5, 6. This will be your answer for the first one. For the second one, 35 by, there is 2 digits, the denominator will be 100. We'll multiply and divide by 100. Reduce it into simplest form, 7 by 20. But for recurring numbers, 0.3 bar, check the method of this. Let x be any rational number which is 0.3 bar. How many digits are repeating? 1. So we'll multiply both the side by 10. So 10x, 10 into x gives you 10x is equals to, this number is 0.3 bar means 3 is repeating. So when you multiply by 10, this decimal is shifted to right hand side. So this will become 3.333 and so on. Now make this previous one as first equation, second equation, subtract 1, equation number 1 by equation number 2. So 10x is equals to 10, directly we are going to subtract it. 10 minus x gives you 9x. Now check this, 3.333 bar and 0.333 so on. If you subtract all after decimal, all the digits are same, so this you will get 3. X equals to 3 by 9, which is equals to 1 by 3. So the p by q form of 0.3 bar is x equals to 1 by 3. Systematically note down this. Now check this, the another question, 1.27 bar. Let x is equals to 1.27, bar is on 2 and 7, that means 27 is repeating, 27, 27 and so on. Make this as equation number 1. Since after decimal 2 digits are repeating, we'll multiply both the side by 100. Multiply both the side by 100. So we will get 100x is equals to, shift 2 digit on the right hand side, 127.272727. You can check that after decimal all the digits are same, 2727. So when you subtract it after decimal point, all becomes 0. That is why now subtract again, subtract 1 by 2. So the 100 minus x gives you 99x is equals to 127 minus 1 gives you 126. X equals to 126 by 99 divided by 9. This gives you 11. 3 is 14 by 11. Let us check one more example. Example is, one more example I am going to take, 0.245. Here you can see that after decimal not all the digits are repeating, but only 4 and 5 is repeating. So for this we opt another method. Let x is equals to 0.245, 45, and so on. First you check how many digits are there after the decimal point. There is 3 digits. So multiply both the side by 1000. Multiply both the side by 1000. We include total digits after the decimal point. So this gives you 1000x, 245.4545, and so on. Now multiply again equation number 1 multiply equation number 1 by 10. The non-repeating digit. How many non-repeating digit? 1. Only one digit do not have bar. So we'll multiply by 10. So 10x is equals to 2.4545. Now you can see in equation number 2 and 3 that after decimal point the digits are same. So now it is easier for us to, when you subtract it, so this after decimal point all recurring digit will vanish. Now 1000 minus 10 gives you 990x is equals to 245 minus 2, 243. This gives you x equals to 243 by 990. This gives you 330, 81. Then again by 110, 27 by 110. So this is how we can do express the decimal either terminating or recurring decimal into P by Q form. Complete your NCERT exercise 1.3 and 1.1.